our canvas page. That look good? Right, I've added a page. Here we go. And it's basically tell you the topics that you need to be aware of for the final. And I'll also use it to tell you the topics that are going to be in the test. There are some missing topics, and that's deliberate. For instance, in chapter 5, we are not going to have in the final any of the numerical, trapezoid Simpson rule stuff, right? That's not going to happen. They take up too long, and they're really not that clever. I mean, they're just math. Well, not even math, they're just number crunching. But, 5.2 is, do you know how to integrate x cubed sine x, 1 over 1 plus x squared, 1 over the square root of 1 minus x squared? Well, let's start with that one. What is the integral of 1 over the square root of 1 minus x squared?
Sine inverse.
Sine inverse, that's the guy. Right, indefinite integrals, add plus c's at the end. Substitution rule. Area between two curves, f of x, take away g of x. Make sure f is on the top, make sure g is on the bottom. Let me jump around a little bit. That way I can do two things at once. If I gave you a function and it looked like this was f of x and this was g of x, and you were going to integrate it from here, say 1 was here, and let's say 5 was here, you wouldn't do this. Because that wouldn't actually get you the right answer. I mean, sometimes it would, but not in this case. What's the problem?
G of x is the function on top.
Well, sometimes. And aren't other times f of x is on the top? So what we have is a problem of a crossover, don't we? And so the area between the two, which is this thing, has to be split. So if you want the area between the two, you have to find the integral from 1 to 3, and f goes first and g goes second. And then you have to find the area from 3 to 5, and they switch places. So if you're being asked to find the area between x cubed plus 1 and x squared minus 1, right, whatever the curve might be, from 1 to 5, shouldn't you, just to be safe, shouldn't you plug it into your calculator and look at it for a minute? Or some software if you're using software. Just in case it's a crossover. And by a crossover, I mean like this, right? It's like a very weird kind of like X shape. You see it? It crosses over. Section 6.2, the next one after area between curves, is volumes. And there's a lot of formula in volumes, isn't it? Rotation about the x-axis or rotation about the y-axis. And the two main methods are the disk and the shell method. Now, with all those guys, I would strongly suggest that you have formulas, write them down on some paper somewhere where they're handy so you can see which formula for which situation. And then if you add on top of that, if that wasn't bad enough, don't these questions also have not just that you rotate about the x and y axis, but you rotate about a line parallel to the x or parallel to the y. And if that wasn't bad enough, because it's already kind of messy, don't you also have f of x and g of x? In other words, there's between two and all those things I mentioned. So although that's just is called 6.2 volumes and 6.3 cylindrical shells, although they're just called those sections, there is a lot of work in those, right? A lot of different permutations for you to keep track of. The next section is called 6.4, which is work. I guess I'll jump back so you can see it. Does anybody remember what happened in the work section?
That was us calculating how many joules it takes to like lift a bucket up
Up a
building
cliff with a hole in it and
with changing weight.
Changing weight and so on. Yeah, it's one of those guys. I guess the only saving grace is they're either very easy, you know, like the bucket weighs 5 pounds and the rope's 10 feet, right? And there's nothing changing, right? Those are very easy to do. Or even if it is the one with a hole in the bucket and so on, once you've seen how to do one of those, don't you just do the same thing with all of them? You just tweak the numbers. You know, the rope will weigh something different and the bucket will weigh something different and so on. So, oh, and in there's another guy, I just remembered now. A totally unconnected guy. It still counts as work. Remember Hooke's law, the spring questions? That's in there as well. Average value of function, I kind of like, or I think you will like at least. Isn't that basically just 1 over b minus a, the integral from a to b f of x? I mean, there's not an awful lot in that. You could, of course, get a secondary part to that says, okay, you found the average function is 5. Now find out the places on the function where the value of the function is 5, right? And then the next section is really technique. Integration by parts, trig integrals, you know, sine cubed cos theta, that kind of situation. Trig substitution, that's x subs. You know, the one where you have a thing and you do x equals 4 secant theta, that kind of thing. Rational functions, basically partial fractions. And improper integrals, you know, the limit is things go to infinity. So, talk a little bit about those kind of guys. That would be integration by parts. Who do you pick for F and who do you pick for G? Because that's pretty much the most important thing that you need. You get that right, the rest tends to come.
X cubed.
Okay. And the sign is a G, right? Of course, you probably should write down, oops, well, you shouldn't write that down. Shouldn't you have that formula written somewhere? You may even want to call it integration by parts. So have a think about what formulas that you know that you are unlikely to just generate off the top of your head. And then the ones you think you know, well, you probably write them down anyway, because you know what happens in a final. You know, the stress gets to you and the formula that you knew like for weeks without even thinking about it has suddenly disappeared from your brain. So, you know, it's not a lot, right? But have it written down, easy to find, you know, so maybe you should have all your formulas in just one page, right? And then details about how to use them or whatever you want to add in a different page, maybe with a heading, I don't know, integration by parts. I'm just kind of giving you clues to how my brain would work if I was getting ready for this kind of final. Now, when we talk about trig, we talk about things like this. What would you do as your u sub, because these questions at least are u sub questions.
Cosine.
Well, for this one. You say cosine? You want to change your mind? Cosine would work, but it would give you a lot of extra work.
Just sine.
Wouldn't sine just come out a lot quicker because it would turn into u cubed? So in that particular question, picking cosine or sine wouldn't matter, right? Both would eventually get you the right answer, right? The correct answer. One would just take you longer. Now make it harder. Who do you pick this time? Because there's one correct one.
When you
And the
pick
other doesn't
sine.
work. Say again?
Sine.
Nope.
Cosine.
Why the cosine? Well, think it through. If you pick a cosine, won't that turn into u to the 4? If you pick a u sub of cosine theta, that bit will turn into u to the 4. Won't this generate a sine theta? Won't that kill off one of them, and won't you be left with sine squared theta? Now, what can you do about sine squared theta in terms of cosine? Okay, I'm doing far too much verbal and not enough visual. So here's this question. And I'm saying that the cosine was a good choice. That's one you should have done. So and when I said you use up one of the signs, I'm talking about what's happening here. So what do I get? I get a u to the 4. I have a sine cubed theta. I have a -1 over sine theta du, and I use up one of the signs. And now I'm looking at that. And so when I said, what do you do with the sine squared? That's what I was talking about, right? What do we do about sine squared? Because it has to be turned into u's, right? It has to be turned into things with cosines. What can sine squared be rewritten as?
Could it be rewritten as like the half angle rule?
It could, but it wouldn't be a good idea in this question. It
The double
certainly could.
angle. Yeah.
No, you were on the wrong path. Think simpler.
1 minus cosine squared?
Yes. Do you see what not doing something for a while can do to your brain?
Isn't that the double angle?
No, it's not. If you think that's its name, then you're okay to do that. The double angle formula would be cos squared theta is a half 1 plus cosine of 2 theta. And that's called the double angle formula. So you may have given it the wrong name, but if that's what you were going to do, then that's fine. It's not a good idea to call something the wrong name, but as long as you use the right thing, it's not a deal breaker, right? That guy there is looking good, but would you agree that I still can't integrate it quite yet? So what do I have to do to all this ugly mess so that I can think about integration?
Distributing it?
I believe, but don't quote me on this, I believe it becomes that. Would this be the final answer? So if I type that into WebAssign, if that was a test question, would that be the correct answer?
We just still have to plug in the cosines.
Oops. Then what we learned from that, that if you don't do something for 8 or 9 weeks, you get rusty. And so maybe what you thought, yeah, I did that section really well, it came to me easy, I'm good. Well, maybe you're not as good as you think. But I tell you the good news. See if you go back and do a couple and just read over some stuff in half an hour, you'll be fine. Yep, yeah, I remember it now, that kind of thing. So that took us through the trig one. The X subs look like this, don't they? Oh, I don't know. That's what they call 7-3 trig subs. In trig substitution, there are where A is a number. There are only 3, right? There are only 3 possible trig subs. And these trig subs are almost always used with weird square roots, aren't they? There's a square root of x squared minus 9, a square root of x squared plus 25. You would probably want to have on a separate piece of paper which one you use for which situation. Does anybody know, just off the top of their head, which one of these 3 would work with this guy?
Tangent.
Correct. Did you know, or was it kind of a gut feeling, or what? How comfortable were you with that choice? It is correct, by the way.
I just know that the plus always means it's tangent.
It's as good a rule as any to remember. Agreed? What does an x squared minus 1? Get you? So there are only 2 left.
Is it sine?
So close. What was the other one?
Secant.
Yeah. Those 2 are very similar looking. You know that you've picked the right one because you could have picked the wrong one. See the bit that's the square root. You forget about everything else, but see the bit that's the square root. In this case, say it's x squared plus 1. If you type in tan squared theta plus 1, that becomes secant squared. And you know you're on the right track, because shouldn't the thing inside the square root be a perfect square of a sine, a tan, or a cosine, actually, is the third one. So if I did 1 minus x squared, for instance, it would become 1 take away sine squared, which is cos squared. And I know that I've got the right one. So just, if you're not sure between the 3, just do a quick test on what does the square root thing look like. And if the square root thing looks like 1 plus sine squared, you know that's not going to go anywhere, so you know that's the wrong x sub. If the thing inside the square root turns into a nice perfect square, you know you've got the right one. But I kind of like, if you see it's a plus, it's a tan. That's kind of helpful, right? Because then you only need to figure out who to do with the other 2 choices, right? You only have a 50-50 to work with. Well, that was good. Any questions right now? I should have kind of put that out there. Okay, so I hope I'm picking up some weaknesses here. And that just means things you need to go back and check on. Like, oh God, that's right. There's another thing with these guys. Let's say you do the whole question, right? And you go through, and the final answer ends up being sine squared theta plus tan theta, right? With a C, right? You know that's not the answer. Right? Let's suppose you had done, making this question up from scratch, let's suppose that was the original x sub, and this is the answer, right? This is what the integral equals. This is not the final correct answer. Don't you have to turn everybody back into x's? Does anyone remember what weird, it was unique, they only do it in this section and nowhere else, the unique way in which we did that?
You have to create a right triangle and figure out x that way.
So you convert it to that, like you said, and you build one of these weird little right angle triangles that always look like that. And this is opposite, this is adjacent, and this is hypotenuse. And for the sine, it's opposite over hypotenuse, right? So we know the opposite is x, and the hypotenuse is 4. So this guy here, according to Pythagoras, would be 16 take away x squared. Now, this is a little bit later on. If you have a square root of 16 minus x squared, as we do here, shouldn't the original integral have a square root of 16 minus x squared in it somewhere? Not a square root of 16 plus x squared, not a square root of x squared minus 16, but of a 16 minus x squared. And if your original integral doesn't have this piece in it, then you probably screwed up somewhere. Maybe you screwed up in the x sub, or maybe you just, try to think of some, that you got one of the trig identities back to front, right? And you thought this should equal that. Something weird has gone wrong, right? And that guy there you can use to build all the guys that you want.
Wait, how do you get the parts of the right triangle?
Oh, so again?
How did you get the, like, did you just make up those values on the right triangle? Where they come from?
Oh, I pretended that this was the x sub that was being used in an equation.
Oh yeah, okay.
And from that you can deduce that this is true, and the sine is the opposite of what hypotenuse. That way I knew where to put the guys. Right, before we move on here, I want to do, and there are, God, there's millions of these little darlings. We're going to do some identities. It kind of depends on what you need, what you got. Sine squared, and sometimes can be written like that because it's helpful. But isn't there a double angle formula for sine squared? Right, another way to write it. Anybody going to go and bite the bullet and volunteer for it?
1/2 times 1 minus cosine 2 theta.
And that might be the form that you convert this into because you're thinking of integration, right? Now, isn't there a cos squared version of the same thing? Cos squared would be 1 minus sine squared, right? And cos squared theta would look just like that, but with a plus. That's just one example of identities. But sometimes you don't have theta, you have 2 theta or 10 theta. You can still do it. It's 1/2 plus the cosine of what?
4 theta.
because you really should think of these theta, 2 theta combinations here as really placeholders. So whatever this is, you get double it. So if this is 2 theta, you get 4 theta. Now that means that I can integrate this fella because I know how to integrate those guys, right? Okay. Here's a reason why identities, and there's millions of the little darlings, are helpful. I would like to do, check I got this one right. Yes, I'd like to do the integral of tan squared. Unfortunately, I don't have anything for tan squared. The closest I've got is that I know the integral of secant squared. Does anybody know the integral for secant squared?
Tangent.
I need to know what identity to turn tangent into.
Tan equals 1 plus secant squared.
So you're saying secant squared plus 1, or 1 plus secant squared. Okay. You see, it now makes the job of integration relatively simple. So I don't know how you're going to deal with the identities because there are just so many different versions. But you're going to have to be aware that just because what's in front of you doesn't work doesn't mean the question's impossible. Maybe it just means that the way the trig thing is written isn't the way that it needs to be written, and you'll have to use trig identities, factor things out, play about with them whatever way needs to be done in order for you to get it in a form that allows you to integrate. This guy here is basically section 7.4 questions. My dog's wanting attention. What technique do we use to do these kinds of questions typically?
Partial fractions.
Right. So I hope you haven't got too rusty because it's been a while since you needed to do them. But remember the process.
You want to make everything have the a common denominator.
Yep. And then what's the trick after that?
After that, it was have to do some on the line with making sure it equals the numerator somehow.
You multiply all the denominators by the other ones to get the same fraction, and then you
Yeah,
can get
that's
rid
it,
of all
yeah.
the denominators underneath
Yeah.
all of it, and then you just solve for A and B.
Right. So let's pretend that you did all that and you end up with a guy that will look like this. So Rick, can you write? Sometimes you have to write things down. It's kind of, if you don't see it in your head. So what's the technique now? How do I find A and B?
Choose different numbers for X to get them to 0 and get A or B by himself.
Right. So do you randomly choose, or is there ones that make sense and the others don't?
Ones that make sense.
And how do you know the ones that make sense?
They're going to equal to 0 typically.
Right. So X equals 3 would get you this, would get you B actually, and X equals -2, wouldn't that get you A? Now, you have to do a slight different version. Imagine you had a question that looked like this. I think if there would be a C, yeah. Okay, so I'll write that again. Don't you have to be selective about your choices of X when they get complicated? See, in this one up here, couldn't I choose 3 and then choose -2 and it would work fine? Or I could have chosen X is -2 first and then X equals 3 and it would have worked fine, right? In both cases. In questions where there's multiples, especially a CX plus D term, you know, the ones that look like that, wouldn't you have to be a little bit more selective about who you pick for your X, right? And each time you pick an X that allows you to do a letter, shouldn't you then replace the letter? Let's suppose we picked X equals -1, or whatever it might be, and we found out what A is. Wouldn't the next line you would put in what A is? And then you'd find another X, and that would get you B, and then you'd find another X. And typically at the end, there'll be one letter left over, but all you do there is pick any number that you like for X as long as the thing doesn't disappear on you. So be on the lookout for, you know, CX plus Ds especially, because when you have ones that look like that, don't you have to be really selective, not only about what values of X you pick, but even the order that you pick them, right? You have to pick this X first, and then you can pick the second X you wanted next and all the way to the end. So it can be a little bit messy here. Now, when you do these questions, you're probably going to have to integrate things like that, which is 3 natural log of X plus 1s. Of course, it might be something like that, which is 3 times the natural log of 2x plus 1, but not just that. This has an extra piece, doesn't it? What is the real integral of that guy?
The first 3 need to be divided by 2.
And that comes from the 2x. If it was 10x, wouldn't it be 3/10? You know, so little, you know, it's a 2, but you know, won't that throw you, right? Now, in that same vein, don't you sometimes have to do that guy? So what's the integral of that guy?
Inverse tan.
But you could get that guy. He's also a version of the inverse tan. Who is this guy?
Would it be inverse tan 2x or?
It will be something with a 2 in it, but on the bottom.
Okay.
Now, you come across that guy. Isn't there a, on my Canvas site, which will be available during your test, your final, and your test, wouldn't you just go there and you'd probably have to look for a guy that looked something like that, right? Because they don't do X's in the thing, they do U's. In that case, wouldn't this be the 2 squared, which is 4, and this would be like your X? And they would say 1 over A inverse tan of U over A, and you would translate that. Because I have seen that sometimes you end up with that, right? Well, I guess you could memorize that one, but you probably won't. It's really ugly. But won't you be able to find that in the PDF online in Canvas. It'll simply be just the sign of U. Not the sign of U, sorry, secant U. Well, I didn't realise how much we had to cover here. So I will return to the list and show you what's still to come. Can you find the integral from 1 to infinity of 1 over x squared dx? Can you find the integral from 1 to 4 of 1 over x minus 1? Remember those integrals where there was vertical asymptotes or it was 1 to infinity? Remember all those guys? That's what 7-8 is about. Isn't 8-1 finding the length of a curve an arc length? It's a kind of plug and chug formula method. In that same vein, areas and surface areas, I would call them. 8-2 is very similar. It is just a big ugly formula. You just have to know which formula goes with which situation. Now, application in physics and engineering. Remember center of mass, x bar, y bar, and plates underwater, hydrostatic pressure. That's what that's about. 9-1, is this y equals x cubed plus 1 a solution to this given differential equation? That's what was asked for essentially in 9-1, right? They gave you a differential equation and said, check, does this guy work or not? Or here is a differential equation. Here are 5 possible solutions. 2 of them work. Find the 2 that work, you know, so you pick number 2 and 4, whatever it is. It's kind of plug and chug. Don't you just find derivatives and stick them in and see that if they work, right? Does the left-hand side combine eventually to become the right-hand side? There's not an awful lot can happen in direction fields. Don't you just go to the software and look at the picture and pick picture 3? And we're finishing with the 2 guys I think should be most familiar with. Variable separable and linear equations. Variable separable is really a method rather than a formula, isn't it? Technique, kind of crossover thing. And linear equation is mostly just a formula. Isn't it just a formula with integrals all over the place where you integrate things? So for your test, you are going to get, I don't know, I have a vague feeling I said this, and if I did, I should stick to what I said first time. Did I say way back that I wasn't going to give you any questions from applications in your test 5? Did I say that?
I think
You're
we
what?
were only doing the 8-2 and then 9-1, 9-2, 9-3, and 9-5.
Well, I'm going to make it easier for everyone. I'm going to be testing 8-2 and 8-3 in the final. You are getting questions on those. So I'm covering it. So it's okay. So we'll make your life very easy for this test. Chapter 9. So for the test, only chapter 9 stuff is going to appear. In the final exam, I guarantee that 8-2 and 8-3 will be given at least one question in the final. So you know you're going to get tested on, you know, X bar, Y bar, and plates under the water, and find the surface area of this curve.
Oh.
Yes, perfect timing. Although I didn't actually get that many questions. So you got to go for it. Ask me anything you want to know.
Can you do
Okay.
19 on the last homework?
I can do 19 on the last homework. Yes. If you wait till the end, anybody else who wants to see it can hang around. I'll do it then. So don't leave. Oh, say hi, everybody, so you get attendance. Right. Any other questions?
Like what time and like how much time would we have for this final?
Your final, Ripken, I'm looking at my piece of paper, is going to be on Wednesday the 9th, and it's going to start at 7 and finish at 10. So it's 3 hours. The WebAssign, I always design it listening to WebAssign. They tell me how many minutes a typical student takes. So it will be designed to take 2 hours, but you're getting 3 so that you don't have the stress of rushing. Does that make sense?
Mm-hmm.
So hopefully, I don't know what, depends on the person. Hopefully most of you by the end of 2 hours will be finished, but you might want to spend another 20 minutes checking all your answers. Well, the working at least for your answers, because your answers are committed, right? It's going to be pretty much like a big test. In other words, you turn up with Zoom and I watch you to make sure your big brother's not helping. And when you're finished, you make sure that you upload all your working into Zoom at the end. Upload all your working, not from Zoom, into Canvas when you're finished. I don't know how you could do it to Zoom. And you'll get an extra half hour tagged on at the end typically to do that. Does that make sense? Okay.
So test 5 is on Monday.
Test
normal
5's on
time.
Monday, and test 5 is 7 to 9 as usual, right? Test 5, I'm pretty sure I mentioned it, but I'll say it again. If you've got 4 really good tests and you don't think you're going to do any better, you're just going to do about the same in this one, you do not need to do test 5, because I'm only going to count the best 4 out of the 5. So that's your decision whether you're going to take that test or not. You might decide that you like chapter 9 and you think you could do really well in it, and you might be able to bump your average test score up by 1% or 2. Certainly worth it, every percent helps. You might say, nah, I'm good. I'm getting 92, 93 every test. I'm probably only going to get the same. I could use that 2 hours to get ready for my final, right? And that makes sense as well. So you're making that decision. You will get attendance for it. So it's if you were here. I'm just going to assume that you're not physically here, but you're here somewhere in the universe, and so you're here.
So if we wanted to get just attendance, could we just come in and say here and not do the
Yeah,
test?
don't even need to do that.
Okay.
You're getting it for free, right? So when I do that that attendance day, well, you'll be present. So hopefully that you use that time wisely, which is what I'm assuming. When finals are coming up, you know that you've got to use every spare minute that you can. So I don't want to use up your time if it wouldn't make any difference to your grade. Any other questions?
Do you know how many questions we'll have on the test and exam?
Nope, because I haven't made them, but I could give you a pretty decent guess. There's going to be 2, 4, 6. There's probably going to be, I don't know. I can't really think of much to do with direction fields. 10 questions. There'll probably be 3 from 9.1, 9.3, and 9.5, and just 1 question from direction field. Because if you can plug it into the software and pick the right picture, doing it 3 times isn't going to prove anything. I mean, you can do it once right, you can do it 3 times right. So there'll be, I would guess, 10 questions. The final is a bigger puzzle. I haven't even looked at that yet. I'm guessing, and this is, don't quote me on it, about 15. Right. So like 5 questions an hour. Right. So that gives you 10 minutes and change for a question. You know your final's 30% of your grades. That's very, very, very important. So do not forget to send in your working, because WebAssign will mark you as a big fat 0 if all you did was forget to put in a +C. So you got to be really, really careful when you do it to make sure that you're showing where you're working. And sometimes your working is so trivial, you know, it was a +2 instead of a -2, that you get virtually all the points. And even if it's only half right, at least you'll get half the points, which is better than nothing. So important, important, important. Do good working. Get it to me. Keep going until we don't need to keep going anymore. Are there any more questions?
Getting the work to you for the final would be just like a test, right?
Exactly. There'll be another, I think it's called Canvas assignment, right? And you upload it, and I hope by now everybody has got the kinks out. Are you all comfortable with using your cell phone or your mum's cell phone, whatever it is you're using, and sending it to me? If disaster strikes, I guess who knows what can happen on the day of the final. You know, you can still send it to me using drobertson@olympic.edu. I prefer you not to do that, because then I have like 100 emails and then I have to figure out who John Smith is and what class he's in, and don't do that to me. But if you have to, yes, you have to, right? So if Canvas just won't load up or some horrible thing like that happens, then you do that. We're having good questions here. I can't think of anything else to tell you, so you got to ask me if there's something you're not sure about. Okay, if you suddenly, after the meeting's finished, thought of, oh God, yeah, I should have asked them that, then you know the usual, send emails to me and I'll eventually get back to you with the answer. If it's some really big question like, oh God, yeah, I should have told everybody that, I'll probably just send out a general email saying, hey guys, this is what you need to know. And now I've said that, I've got an idea. This is note to me. I'm going to send out an email with useful things to know to do your final, right? Just so that if I come across something I forgot, I'll put it in. So I'll mention things like, please do your working, or please, please do your working. So remember, you got to tell them 3 times. Yeah, I'm good. Okay. A kind of anti-climax again. It kind of just peters out, doesn't it? So I'm going to hang about and do 19 for those who want to see it. And for those who have to go away because I've got a class to do, you can always watch this video and find out what question 19 was about. And you can also watch this bit in the video to say, what did he say again about whatever it was? And you can hear it again. Okay, it looks like I've been asked to do a question, if I'm not mistaken. Question 19 from the last section. Was that what you said?
Yeah.
Okay, let me get that loaded up and we'll see what the heck is the problem. Oh, excuse me. Oh, that is not the right link. I'm hitting the wrong things all over the place. Here we go. That's the right link. And log in and sign in. And linear view open. Scroll down. Okay, I'll be putting it on the screen in a minute just to double check that it is 19 and it's the same 19 that you're talking about. Okay, so the question is a linear differential equation, and try that again. It's a linear differential equation.
It's got that weird y-1 in it.
I don't have a weird y-1 in mine. This is my 19.
Yeah, there it is. By the 3x. I'm not really sure what to do with that.
Okay, so we have an x squared plus 1 dy by dx plus 3x brackets y minus 1. Okay, I can see what you're talking about. And then a y of 0 equals 8. So let me nip back and show you what to do with that y minus 1 fella. Yeah, sometimes you have to adapt to unusual circumstances. First line is to distribute it. Next line is to add 3x to both sides. Do you know what I'm going to do next?
Probably divide by x squared plus 1.
I am. You're right. So it's now in its linear form, right? So basically that was done by just doing this, right? We cool so far?
Yeah.
Okay. So the p of x is going to be this unusual guy. And the q of x is, by sheer coincidence, the same thing. So the integrating factor is e to the integral of p, which is e to the integral of 3x over x squared plus 1 dx. And for something like that, I would do some working at the side. Do you recognize the method that I should use to get this integral?
It seems to me like a u sub.
It does indeed. And who's the u sub going to be?
The bottom.
Yeah. So if I differentiate with respect to x, I do the crossover, then I isolate. We can now do 3x over u times 1 over 2x du. The x's cancel, and you see that 3 halves? I'm just going to bring it outside because it kind of clutters up the process. 3 halves, which gets me a natural log of u, which in turn becomes that guy. While I'm here, I think I'll do my algebra here. I'm going to try and make this a little bit prettier by bringing everything inside the log. Now, if that was 2 log, wouldn't this be squared? If it was a half log, wouldn't this be a half power, right, a square root? It's 3 halves. Are you comfortable about that?
Yeah.
A multiple of a log becomes a power.
Yep.
So this fella, question?
No, I said yeah. Just agree.
Okay. E to the natural log of x squared plus 1 to 3 halves. We know how these two play well together because that seems to be almost every time what happens. We now have an integrating factor. It's this guy. Okay. So, solutions. Y equals 1 over the integrating factor, the integral of ix qx, 1 over x squared plus 1 to 3/2. The integral of x squared plus 1 to the 3/2. Lost the damn thing. Times 3x over x squared plus 1 dx, I'd say. If you want to make this guy different, then I'll convert him to a negative power. You know, this guy here cancels out most of this guy. This is x squared plus 1 to the power of 1, and then x squared plus 1 to the power of 3/2. When you cancel these out, do you see that you still are left with an x squared plus 1 to the half? And the 3x is still there. Are you comfortable about this becomes that?
Yeah.
Right. Now, if it wasn't bad enough, I now have to integrate this fella. So I would do that as working on the side. What technique do you think I'm going to use to integrate this fella?
Integration by parts.
So we are looking at a u equals x squared plus 1. And all that stuff that I did earlier, I'll just cheat and use it again. So this becomes 3x u to the half, 1 over 2x du. The x's cancel. I'll bring out the 3/2, and we get this guy. We add 1 to the power, and then we divide by the new power, which perfectly cancels this guy out, which is nice. And that becomes x squared plus 1 to 3/2. See, this gets cancelled by the 3/2. Are you okay with this becoming 1?
Mm-hmm.
Okay, so back over here, we now have x squared plus 1 to the negative 3/2. The integral is x squared plus 1 to the positive 3/2. Add a c. And if you distribute, right, multiply these two together, something really cool happens. What do they get when you multiply them together?
Just 1, right?
Yeah. And then the other one's not particularly nice, but okay, so far so good. Right. Now, we had a y of 0 equals 8. And isn't that guy's job to give you c? So that's telling me that when x is 0, y is 8. So 8 goes here. 1 plus c times nothing squared plus 1 is 1. And 1 to that power is just 1. Right, 0 plus 1 is 1. 1 to a power, doesn't matter if it's negative or not. 1 to the power of anything is essentially 1 as long as the power is not 0. And we have, and that gets me C. So our particular solution is done. Are we good? Any steps not sure about?
Yeah, I'm all good. Just, I don't know why I didn't think to distribute.
Well, you never saw it in any of my examples, but you know, we don't have the time to think of every permutation. So sometimes you got to say, look, it has to work. And you just play about with it. And now that you've seen that one, that kind of stops that being an issue. But maybe the next time a different circumstance happens, you're going to say, okay, there must be some algebra here, right? What are my options? I can factor it, I can FOIL it, right? I can distribute it, I can combine like terms, and I can move things around, right? They're the basic building blocks for every algebra, right? And so you look at those guys and you see what, which of them is a good candidate for getting what you need. There is an added subgroup. God, they drive you crazy. Trig identities don't play by the same rules. Because sine squared plus cos squared turns into 1, you know, but sine squared minus cos squared doesn't turn into anything even vaguely like 1, right? So you just have to play about with them and hopefully it's something that you've seen a similar circumstance to. Okay, I am good unless there's another question. Are we good for today then? Right. If anybody, I guess, has a question, but they wanted just to ask me personally and not in front of the others, you can wait behind. You could tell me that you're that person, so I know not to just close off.
Thank you.
Okay. So bye-bye, Trenton. Matthew, you got a one-on-one question. I'll make sure this is cut out the video of you.
Oh, no,
What?
no, I don't. I was just, yeah. I was just
Okay.
saying to see the problem.
Okay, then we are good to go.